This is the bicycle top assembly video, part 5. At this point, you've completed everything there is to do for this bicycle project, with the exception of the documentation. For the final step, we will be making a 2-sheet drawing. This won't be a detailed engineering document with dimensions, but think of this more as a drawing which is documenting a design concept. The first sheet shows 3 orthographic views of the fully assembled bicycle. These are shown using the hidden line remove display style. Then a 4th view is added in isometric using the shaded with edges displayed style. The second sheet is going to show an exploded view of the frame components before they are welded together. This sheet includes a bill of materials for the frame and bubbles pointing to the various frame components that correlate with the item numbers in the bill of materials. We also have a little bit of annotation on both sheets. Before starting, you should have your entire bicycle assembly completed. However, don't worry if you have to go back and make changes. Those changes will be reflected in the drawing. You also need to have an assembly file of the bike frame components completed, and this assembly file needs to have an exploded configuration added to it. Ideally, when you made this exploded view, you did it with a particular viewpoint in mind that you're going to be seeing when this explosion is in the drawing. In my case, I made a custom view, and I saved that view. In this case, it's custom ISO. And this is the orientation I plan on seeing in my drawing. It's possible that you did not make a custom view and were planning on just using the isometric view, or maybe you weren't thinking about a custom view when you had the frame oriented a particular way. If you want the frame to be oriented a particular way in the drawing, make sure you have it oriented while we are looking at the assembly. Hit your space bar, click on New View, and then type in a new view name for that, and OK. Later, when you insert this assembly into your drawing, you will actually be able to pick this custom view for the drawing. Now, before I start, I think it's convenient to have both my bicycle top assembly and my frame assembly open in Solidworks. Now I will begin the drawing process by going to File, New, Drawing, OK. And for this drawing, we want to use a B-size sheet, which is 11 by 17. We have an option of displaying a sheet format. This is the type of sheet format that's often used in engineering documentation. But as I mentioned before, we are just making an industrial design concept, and this won't be a controlled document. So I'm going to uncheck Display Sheet Format, which is going to leave us with a blank sheet, and I will say OK. And for now, I'm going to X out of this Model View Feature Manager. Let's get rid of this, and that's going to leave us with a blank sheet that's 11 by 17. Here in the feature tree, we see Sheet 1, and down here we have a tab that says Sheet 1. The first thing we want to do is right-click on that tab, go down to the bottom where it says Properties. Unfortunately, this is appearing off of the camera view. So I click on Properties. This brings up a box that indicates the scale that the sheet is set at, and it also has the projection type. First angle projection is used in Europe, third angle in the United States. We definitely want to make sure that this is checked on third angle. Now we can say OK, and we are ready to add some views to this drawing. Go to the View Layout tab and click on Model View. This will put into the Feature Manager box the 2 documents that are currently open, the top assembly and the bike frame. We want the top assembly. We'll click on that, and if we're not sure if we have the right document here, we can always open up the thumbnail preview, which shows us what that document looks like. Then we have to go to this blue arrow that says Next, and we choose the view orientation that we want to use. The default when we add a new model view is to go to the front view, and that's what we want. So all I have to do is bring my cursor out into the drawing area, and we see a preview of the size of the view, and just left click down And there is our view of the bicycle. I'm going to hit the escape key and hide all types so I don't see all the sketches that were present in all the different parts. Now, if we look at the bottom here, we see that Solidworks has tried to help us with the scale of this view and has changed the sheet scale to 1:20, meaning we're seeing this at a scale of 1/20th of real life size. If I right click on sheet 1 again and go to properties, I see here it's also been set 1:20. I think something like 1:4 or 1/4 scale is going to work a little better. Actually, that's way too big, so let me try one more time. And I will change this to 1/10. And that looks like it'll probably fit when I add some additional views. We can change this as many times as we want. I've got my front view. I'd like to have a top view and a view on the right side, which is actually looking straight at the front of the bike. Clicking on this view, I now go up to projected view and I drag upward, giving us our top view. Now clicking on our view again, the front view and projected view, and this time drag in this direction, it gives us the right side view. If I drag to the left, we see a left side view, and if I drag downward, we would get a bottom view. Now we want to add that isometric view over here. So once again, we have to hit model view because this view will not be projected from any of these views. So model view, we're already set up for the top assembly. Just hit next. This time we want to select an orientation that is isometric and drag this out into place. SOLIDWORKS has again tried to help us out by making this a scale that is way too small. If we simply click on this view, it opens up a feature manager just for this view. And if we scroll down to the bottom, we see that SOLIDWORKS has assigned a custom scale to this view instead of using the sheet scale. If we want this view to match the sheet scale, all we have to do is click on Use Sheet Scale, and we see the view has gotten larger. And there's no reason why this has to be at the sheet scale. We can always make this a little bit bigger or smaller if we have to, just by going to Use Custom Scale, going down to the User-Defined pull-down, and then choosing the scale we want. And if none of those satisfy us, just click on User Defined, and that lets us type in exactly the scale that we desire. Right now, simply using the sheet scale seems fine, so we will leave it at that, and then click out of this feature manager. I mentioned before that I wanted this view to be shaded, so I just click on this view, go up to here under Display Style, and this is the same display styles that you normally find in your part files, and we will go down to Shaded with Edges. This display style for the orthographics that was set defaulted to Hidden Lines Removed. If it didn't default to that, all you have to do is change that with this control. If we zoom in, we see that all of the lines are showing, including the tangent lines. And this can get very distracting in a highly detailed drawing like this. So what you can do is right-click on the view, go to Tangent Edge, and set it to Tangent Edges with Font. It changes the tangent edges to have a centerline style font at a thinner line weight. So you can still see the tangent edges, but they're a lot less distracting. I find this to be more pleasing to look at. Now you have to do this for each of the views individually. It won't update the other two views if you do it on the front view. On the shaded view, you might consider another option. Right-clicking on that view and again going to Tangent Edge. You might want to change that to Tangent Edges Removed. And that will leave the edges wherever parts come together, but those tangent edges will just be seen by virtue of the shading and not virtue of any lines. Now we added a front view, top view, and right side view, and these are actually the standard 3 views. So if I delete these, I can show you a different way to add these views. I click on the standard 3 views, I select once again my top assembly, hit the green check mark, and that drops in the 3 views for me automatically. Unfortunately, it decided to rescale them once again, so I have to go back to my properties, right click, go down to properties, and I see that the properties haven't changed, so what it must have done was change the scale on the view itself. So clicking on this view and going down to the bottom, I see yes, it did change it to a custom scale, so I just use sheet scale in this case, and that has brought it back to the scale that I want. And I would have to go back and change those tangent edges again. So this is just 2 ways to add the views. Using the model view and projected view gives you more versatility. Using the standard 3 views always gives you the front, top, and right. Before we add our second sheet, I'll point out that in the feature tree, we have sheet 1, and under sheet 1 are 1, 2, 3, 4 drawing views. Drawing view 4 is this isometric view. Drawing view 8 is this front view. Views 9 and 10, which have different icons on them, are projections off of this drawing view number 8. Now we are ready to add our second sheet. Go down to the Sheet 1 tab, right click, and unfortunately again I can't get to this to show on the screen, but the second selection down says Add Sheet, and that brings up a brand new Sheet 2 which is blank, and we see Sheet 2 popping into the feature tree. For this sheet we are going to be adding the exploded frame. So we go up to Model View, and this time we choose the bike frame assembly, not the bike top assembly. We choose the next arrow, and we want to pick that custom view that we used for our explosion, and it appears down in this box here, not up here. So clicking on custom view, dragging out into my graphic area, there is the view of my frame. But we see it's not exploded. So right click on the view, go down to properties, and we see here show in exploded state. Check that, okay, and there's our exploded view. Now once again SolidWorks has tried to help us with the scale, and once again it hasn't done a very good job. So I'm going to make the scale of this drawing about 1 to 4. Going down to properties, which again you can't see here, and changing this from 1 to 10 to 1 to 4, now I'm filling up my screen a little bit better. That might be just a little bit too big, so let's change that to 1 to 5 because we need some room for our bill of materials up here and some balloons that are going to go around the perimeter of the view. Once again, we see all these dark lines along the tangent edges, so I will right-click on the view, tangent edge, and click on tangent edges with font, and that gives a softer look to all these tangent edges. The next step then is to add our bill of materials. So we go up to Insert, Tables, Bill of Materials, and it asks us to select a drawing view to specify the model for creating the bill of materials. Well, the view is our frame explosion here, so I just click on that view. I can accept all the defaults that are here in the feature manager. There should be nothing I have to change. And then I can just click on the green check mark here and drag out to this corner my bill of materials. Zooming in, we see that this is taking up quite a lot of room and is interfering with our view here. So we want to fiddle around with this a little bit to make this a little smaller. One thing we also notice is that we have 4 columns: item number, part number, description, and quantity. The part number defaults to the file name of the component that was inserted into the assembly. Normally in an engineering organization, it's common for the file name to be named after the assigned part number. So that would pop in to this column. Then you would have a description explaining what that part number is. So you see right now this part number is so long that it's filling up 2 lines in each of these boxes. So I can grab this just like a spreadsheet, and with my left mouse button just drag this out far enough so that I don't have any 2-lined part numbers. So now everything is just on a single line, and I can use this arrow in the corner here to pull this back into place. And most bill of materials I've seen always have the quantity immediately following the item number. If I click on this column and get this arrow and very slowly drag to the left, if you do it too fast it doesn't want to work, then I can rearrange the order of the columns and put the quantity right between the item number and the part number. Now we see that this is pretty crammed in here, so we can fix all of this by right-clicking in the corner of the table, going down to Formatting, and then choosing Row Height. And a good row height is about 6 millimeters. So that neatens everything up and makes them consistent. And if this is still taking up too much room, what you can always do is change the font that's being used in the table. Right now this is defaulting to a 12-point font, and it's fairly wide, so we can choose something else by going up to our options, selecting Document Properties, and then going to Tables, Font, and we can choose something other than Century Gothic, which is a fairly wide font. So we can choose something like Arial, which I'll just type in here, and we can choose Narrow, and maybe we can make the font a little smaller too. So we'll change this to points, and maybe we'll make this a 10-point font instead of 12-point. And then we say OK, which unfortunately is down off the bottom of our screen. Now what you see is it's made the font a lot smaller and a lot more compact. So now that we've done that, we can start tweaking these columns a little bit to get ourselves a nice, tidy bill of materials. Now I can move this over to the corner here a little bit more and maybe move this view a little farther out of the way. Zooming back in here, we need something for the description, and what we can do is just type in the description at each of these spots. So starting with the bottom bracket shell, I'll just double click on this box. It says the cell value is linked to a property in an external model. I want to click on Keep Link. What will happen is when I type into this cell, it will actually add a property in the file for the bottom bracket shell. If I ever use the bottom bracket shell elsewhere and make a bill of materials, the description will automatically fill that bill of materials the second time around. So here I'm going to just type in, using capital letters, bottom bracket shell, and finish that, move on to the second one. It's just going to keep asking me if I want to keep the link, so I will say don't show again, keep link. And here I will type in break bridge and keep moving along, chain stay right, and I won't bore you with typing all these in, but you can see pretty rapidly that this column is wider than it needs to be, so we can go back and resize this a little bit, and again move this off in the corner to make more room for the rest of the drawing. Now that we've done that, we can start adding the balloons that correlate with the item numbers in the bill of materials. Move that over here a little bit. To do this, we go to the Annotation tab, and we have a choice of manually adding the balloons or using the Auto Balloon command. If we manually add the balloons, then we have to check each item one at a time, and what it does is it adds a balloon with a number, and this number corresponds to the item number in the BOM. Let me delete those. The other method is to use the auto balloon. If I just click on that and click on the drawing view I want the balloons added to, you see it's automatically added all of these balloons. And it's in a somewhat haphazard orientation, so now you have to go and clean this up. If I click on any balloon, you'll see that it's got this magnet line, as it is called, that the balloon is attached to. The nice thing about this magnet line is that the balloons attached to it drag along with the magnet line and give us a nice, neat look to the layout of the balloons. But you can drag the balloons independently of each other while keeping them on the magnet line, or you can actually drag them off the magnet line. So what you do, you can just move this stuff around until you get a more pleasing layout with none of the balloons going off the edge of the sheet or interfering with each other or with the bomb. You might also want to tweak where the arrows are actually pointing. Sometimes they might not point exactly where you want, so you can always grab the end of an arrow and move it somewhere else. If you move the arrow onto an edge, it stays as an arrow. If you move it to the center of a surface, it turns into a dot. You see this little U shape. This isn't actually a U, it's supposed to be a magnet, so it indicates that this balloon is attached to this magnet line. If you use the manual method of adding balloons, you still have the ability to add a magnet line if you want. You have this magnet line here. You can just click on one of the balloons to add a magnet and drag that out and even pick up other balloons, and that gives you a magnet line that way. Sometimes I find it more convenient to add the balloons manually rather than using the auto balloon and then having to go back and tweak each and every one to get it to look good. Now let's assume that you've got everything just the way you want it. We have just a little bit more documentation we want to add. We want to tell somebody looking at the sheet what it is, when it was made, who's responsible for it, etc. So we go up to Note, which is under our Annotations tab. Click on that. We can just drag a note off into this area. If we click the note down while we are highlighting a view, that note will be attached to the view and will move if the view is also moved. So we want to try to get this off of the view and click off into this area. I'm going to type in Project 9 Bicycle. Let me zoom in a little bit on that. Return DSID129, fall 2013, and maybe today's date, 12/14/13, my name, and finally, sheet 2 of 2. And since this is the title of the drawing, I might want this to be more prominent, so I can highlight this with my left mouse button, and I can change the font on these particular items I've highlighted. So I'll change that from 12-point font to about 16, and I can even make that bold. So here we see the title and then the additional information. I want to add a similar title to the front sheet, but I don't want to go through the trouble of retyping all this. So I just click on this, Control-C for copy, move to sheet 1, click in this area, Control-V for paste. Now I just zoom in again. And of course, this is sheet 1, so I just edit that by double-clicking, changing that to sheet 1. So that's pretty much it. I'm done with the drawing. I can now save it. And I probably want to just leave the default name. Default name of the saved file will be the name of the first part that was inserted into this drawing, which was our top assembly. So that seems like a pretty good name in this particular case. Before I close this video, I'll go back to sheet 2, and I mentioned earlier that when we type a description into this column, it will automatically update a property in the part file. So let's go to this bottom bracket shell, for example, and see what I'm talking about. So here's my bottom bracket shell. If I go to File, Properties, this Properties box opens up, and I have properties that can be added to any part. In this case, I have a description property that's been added into this file, and under the value for that property is bottom bracket shell. And this is what I had typed in the bill of materials. And so that's linked, that bill of materials, to this property. When I save the bottom bracket shell, this property will be retained in this file. And again, if this is reused in another bill of materials, it will automatically appear in that bill of materials. So that completes this drawing and the entire final project for this semester. Congratulations.